So now we're going to step up our factoring in this slide. In the next couple, we now have a leading coefficient that's not 1. There are two major ways to solve when the leading coefficient's not a 1. The first way, as it says there, is trial and error. Let's start with that one first. Since we have 5x squared as our leading term, then that means in the factorization we should expect a 5x and an x. We're very lucky for this problem that 5 is prime. If, for instance, instead of a 5, if it were 12, then we would need several pairs. We would need 1x and 12x, and 2x and 6x, and 3x and 4x. So as you can see, trial by error is already taking us a lot of time if we have something that's not a prime number. But again, we have 5x, so we're good to go. Let me erase this real quick. And now for the -3, to make a -3, that means we would need in the latter part of each binomial a product to make -3. Well, -3 can come from 1 and -3, or -1 and +3. And here is the problem. We don't know where the 1, -3 or the -1, 3 goes. And what I mean by that is we could have 5x plus 1 times x minus 3. We could have 5x minus 3 times x plus 1. So notice I kept the 5x right where it was, I kept the x right where it was, and then I moved around the 1 or the -3. But we could do the same thing for the second pair. We could have 5x minus 1 x plus 3, or 5x plus 3 x minus 1. So because there are two options for the 5x squared and there are two options for the -3, that provides 4 total options, 2 times 2, for the possible factorization. One of these is correct, and we have to check them now. To check them, you'd have to check the inner and the outer. The inner and the outer will make the -14x. So if I do inner here, I get 1x. And if I do outer here, I get -15x. And we are lucky because what is 1x plus -15x? Notice that does give you -14x. Which means that the final factorization is 5x plus 1, x minus 3. We don't have to check the other 3. These are all wrong. The first one was the correct one. So trial and error, it does work. It takes a lot of time, and it's because of the different options you might have. Again, our 5 and our 3 were prime. If they weren't prime, we would have a lot more work to do. Now let's do the same problem again using factoring by grouping. In factoring by grouping, actually let me clean up the slide real quick. Yay! Much better. In factoring by grouping, you have to remember that A is declared to be the coefficient of x squared, B is the coefficient of x, and C is the constant. So our A is 5. Our B is -14, and our C is -3. To start off factoring by grouping, we do some work off to the side, and we multiply 5 times -3. Five times -3 is -15. And then we ask ourselves, what are the factors of -15 that add up to B, -14? We only have one option here, namely -15 and 1. So instead of the -14x in the center there, we rewrite it as -15x plus 1x. And the reason where those numbers came from is because negative 15 plus 1 makes negative 14. So we use these two numbers to break up the bx term. Now that it's broken up, we will group 2 by 2. So we group the first two and we group the last two. Grouping the first two, notice we can factor out a 5x. And if we factor out a 5x, we would be left with x minus 3. From the second group, we can factor out a 1, and we're left with x minus 3. So notice this is sort of what we did in the past couple sections. They both have a factor of x minus 3. And if I factor that out, I'm left with 5x plus 1. Factoring my grouping, I think, is a little bit faster than trial by error, especially if you're working with non-prime numbers. Also, I think it's a little more visual. It takes out the trial and error completely. It's a very direct way of factoring when your leading coefficient is not a 1. The only comment I want to make is when you go to break it up, how we had a negative 15. Oops, I wanted a highlighter. There we go. If you have a negative 15 and a 1, notice we put the negative 15 first. You could technically put the negative 15 second, meaning you'd have you'd have positive 1x minus 15x. But the reason this way was preferred is because, remember, if your third term is negative, and again, this will give you the correct answer, you just have to be careful. If your third term is negative, when you go to group 2 by 2, you need to keep the negative with that third term and then sneak in a plus sign. You'll still get the same answer. The intermediate steps will look a little bit different, but you'll still end up at x minus 3, 5x plus 1 in either order because multiplication is commutative.